Welcome back. Similar to how we solved two problems after we discussed the concept of elevation of boiling point, we're going to do the same for depression of freezing point. Now, first let's understand what does depression of a freezing point actually means. Okay, I'm going to actually do something more mathematically to actually show you, because I think a lot of people actually get confused with, because when you talk about freezing point, you know, water, okay, freezes at 0 degrees Celsius. Okay, now this is the only time where freezing point has actually a neutral value, that it is neither positive nor negative. Okay, so when we say you add a solute to water and the freezing point is, say, -4 degrees Celsius, okay, the depression, what it refers to is that it's gone from a neutral value, okay, to a -4. Okay, that means hopefully this idea of going from 0 to -4 will help you answer that conceptual question I asked you. Why does adding salt over sugar, sawdust, or any of the other substances to water is a better idea, right? So compared to -4, okay, -12 takes a lot longer to freeze. Okay, so say -4 degrees freezes at a certain temperature. -4 degrees is the current temperature on the road, and say this is a current temperature on the highway, and say you're adding salt, okay, and if you're going to reduce the freezing point of that road to, say, this is the reduced temperature, even though the current temperature is still -4 degrees, okay? Adding salt, you're pushing the temperature to -12. So, which means unless the temperature of the road or highway falls to -12, the salt should work, because the salt is taking the temperature from -4 to -12 degrees Celsius, okay? So unless the road temperature falls at -12 or below -12, then it probably won't work, because this is how much it means. It can only reduce it 8 degrees from -4 to -12. But in sub-freezing conditions like northern Canada, where the temperature can easily go up to -25, -30 degrees Celsius, maybe salt water is not adding salt to road might not be of much help. I'm just saying under this condition, because this is the most that salt can push the temperature below. Okay, so -4 is a much higher temperature than -12. Okay, out of these two, say -4 degrees and -12 degrees, -4 is at a higher temperature, okay? -12 is a much smaller value, so this is lower temperature. So hopefully I have given you the idea on why we add salt or sugar. And so what is freezing point? And there's a common demonstration that most of you have seen is, let's say this person has a bunch of ice cubes, okay? And he sprinkles some salt over it, okay? Hopefully you can find answers to this as well. And he puts a piece of thin twine thread or something of some size to it. And you don't want the thread to be too thin. You want some meat to the thread. And then you could actually give it a couple of seconds, and then you would actually be able to pick the ice cube sticking to it. If, say, this is the ice cube that I'm interested in, I sprinkle some salt, this is salt, and this is my thread, and you should be able to pick it up. And this idea of the thread being able to pick up the ice cube has directly consequence to this idea, okay? But there's a little bit of additional knowledge. Well, you can try this yourself at home. You got to be very careful. You don't want to pick it with a lot of force. It's not like glued by some kind of glue, okay? So you got to handle it gently, but this is doable. Take some ice cubes, bunch of ice cubes, put salt, enough salt on one piece of the ice cube among the ice cubes you have. So this is your cup. And then put a thread on top. Give it a couple of seconds, maybe a whole minute, okay? And then lift the thread. The ice cube will come with it. That's related to this phenomenon of adding salt to the highway to reduce the temperature. Okay, so if you want to try it, try it. So that's a freezing point, is essentially you go from some temperature to prolong the temperature at a much lower temperatures. That way you can actually be able to drive on the road, right? Now, similar to freezing point, delta TF is the depression of freezing point. This is the freezing point constant, and M is molality, and high is Van 't Hoff factor. Okay, you do not again have to memorize this equation, and this will be given to you. So this is the Van 't Hoff factor. And again, for compounds other than ionic, I is always 1. M is the molality or mole concentration, and Kf is again a constant which will be given to you. All right. So instead of explaining it more, in a more complicated terms, I explained the concept of depression of freezing point using the phenomenon of highway and why we salt highways, and with this additional demo. This is something you should be able to try whether you live in a dorm or a house, or you can always find ice cubes and salt and a thread. Okay, this is something it is doable. It doesn't take very long, and you can give it a shot, see if it works. And then if you do, go back into Google or wherever you want, or find an answer to why this happens. You would see that this is related to this, and this is the equation that explains the phenomenon on depression of freezing point. And so we're going to do 2 problems, one involving a polar compound, the other involving ionic compound, and then we can then answer and see which one would be a better option for a road highway. One is sugar or salt. All right, so stay tuned.